mean, I could.
I can watch the chat.
Okay, who do you listen to?
Me? Only ever.
I will log in and watch the chat.
Somebody watch the chat on Zoom, because this is our participants are remote. You want me to make this a slide?
I'm making the slide.
Okay, Slack and then Zoom. Wallace, you on there?
Yep, I just joined.
Thank you. You're my
I have
favorite. That's why you're my favorite now.
What about the Tranau?
Right? Well,
I know what you do.
it's a tutorial, so here we go. So this is my one slide because I want to get to the panelists. So this is the cimilieu, which Henry taught us to say a few years ago. And there's another session on Thursday that's covering like community organization type things. And the cimilieu is huge. Like, we'll get to that like next year. This one's covering computing service providers. So we have Richard Gerber, from Lawrence Berkeley National Lab. Susan Merriger from Cornell is going to cover the Exceed and Frontera somehow very quickly. Lauren Michael from University of Wisconsin-Madison is going to talk about the Open Science Grid, and Frank Witzman is going to cover the DoD systems. And I want to stop talking so that they can talk, and we'll have discussions later. So now, do you want to, speakers, are you all here? Rick, do you want to do it in order I have? Richard, do you want to go first?
Sure, I'll go ahead and start. Can you hear me?
Yes, and
Great.
Okay, let me.
I can share my screen here.
Perfect. Does that look good to you all?
Great.
How's that?
That's terrific.
Okay, great. Okay, so hi everybody. My name is Richard Gerber. I work at Berkeley Lab. I work at NERSC, which is a national HPC center run by the Department of Energy here in Berkeley. And so I know NERSC the best, but I'm going to mention a bit about what the Department of Energy has in terms of HPC resources. And go ahead, I'll go over things pretty quickly, so go ahead and ask me questions, or I don't know if you're saving questions till the end, but in any case, if you look at DOE has two main parts. One is at a very high level. One is the Office of Science, and Office of Science conducts open science research. So it's open to any scientist in the U.S. doing research of relevance to the office. And then there's the National Nuclear Security Administration, which also runs 3 large computing systems well, 2 or 3, at Livermore, at Los Alamos, and at Sandia. So those are machines that are pretty much dedicated to doing national security things, and in particular stockpile stewardship. And they do have some science programs that run there, but I believe they're all in collaboration with scientists that work at one of those labs. So the Office of Science facilities are open to, again, any researcher who wants to use them in the country. The difference between NERSC and the leadership facilities at Argonne and Oak Ridge is that NERSC is a DOE mission-centered center. So we support research that is of interest to the Office of Science, and I'll say a little bit more about what that is in a minute. But the awards of time are made not by us, but by program managers in the different science offices in the Office of Science. So you apply through us, but they actually make the award decisions for most of the time. At the leadership facilities, most of the time is given out through a competitive process that anybody can apply for, called Insight. And the awards of time are made by peer review and a panel that also looks at computational readiness. And the idea is just to do world-class leadership type of science on world-class leadership type machines. Now, all of these systems at all these facilities at both NNSA and the Office of Science labs are on the same order of magnitude. They're all machines for doing science at scale. So that's the one big thing that they have to offer. So I'll say a little bit more about nursing in particular, and how to apply at these other centers in just a sec. So again, I'm from NERSC, and we are, as I said, the Mission Science Center. And so these are the areas in the Office of Science. So some people, certainly didn't realize, but the Office of Science gives out more research grants in the physical sciences than any other organization in the US. So we have a lot of people doing a lot of research. And again, it's mostly physical sciences. The areas that we really don't cover are kind of humanities type of things and medical research. So if you're doing research in any of these areas, you can apply to use time at NERSC. You don't necessarily have to be funded by the Office of Science, but it's certainly a big advantage if you are. Again, real quick, we have users all over the US and all over the world. We are very scientifically productive. We had about 2,500 referee publications that acknowledged us last year. And we do simulations at scale, but we're also, and particularly more recently, are doing a lot of support for data-intensive projects and for AI and learning as well. Again, there's our focus on science. Let's go ahead and skip that. We right now have one big system, which is called Cori. We name all our systems after famous scientists or engineers, and you can read about Gertie Cori, who was the first American woman to win a Nobel Prize in science. So Cori is a system. It's a large system. It's got over 10,000 nodes, and it is a bit of a transition system from kind of the traditional CPU towards a more energy efficient system. So it's mainly composed of this Intel Xeon Phi, what are called KNL. That's an Intel code name for Knight's Landing. Many core nodes. And each node has 68 cores, but they are relatively low speed, I think about a gigahertz, 1.2 gigahertz. But they have various architectural features that allow them to be more energy efficient, like vectorization. They have some very fast memory that's actually on the chip. But because of the slower clock speed, they are a bit more difficult to program for some application programmers. And so you really have to take advantage of the architectural features. But I said it's a transition system because this is really what's coming in the next generations of systems, are systems made out of components that are more energy efficient, but maybe a little bit more difficult to program from a traditional standpoint because you need to program for some kind of fine-grained parallelism, whether it's through GPUs or some other architecture that may come along. We're also doing a lot with supporting experimental and observational facilities. This is kind of a new area that HPC in general is moving into. So we already have a lot of collaborations with various experiments, and we have this idea of this super facility that ties together through networking and computing and other analytics and mathematical tools, this idea of being able to quickly acquire data, analyze it, get immediate feedback, perhaps for real-time steering, for real-time analysis. You know, maybe if you're taking pictures of supernova at night, you want to know right away when one goes off, so you can train other telescopes at it and that sort of thing. So we are building that. Our next system is going to be called Perlmutter, and it's arriving in 2020, and it will be most of the computational power will come from the GPUs that will be on the system. But for us to also support people whose codes are not yet GPU ready, it'll also have a pretty large CPU-only partition. So this is something we definitely expect to be seeing more of. Our systems are more heterogeneous with different kinds of architectural components to serve different needs. It will also have an all-flash 30 petabyte Scratch file system. And this is, again, to try to support more of the data analytics, learning, and that sort of type of workload. So how do you apply for time at NERSC? There's got some links here. You can use NERSC, again, if you're funded by the Office of Science to do your research, or your research is relevant to the mission, which you can read about at the DOE website, and you need computing and or data storage or analysis needs that are greater than what you have at your local resources. So generally things are run at scale or some other feature that NERSC, unique architectural feature NERSC might have, some unique capability. We're not trying to replicate things that are going on at local institutions or in the cloud. So we're trying to set ourselves apart from those resources. And you can apply here, you can apply throughout the year, but most allocations are done once a year in the fall, and most of the time is given out then. You can also get startup accounts pretty easily that give you access to a small number a small amount of computing for about 18 months. And oops, I skipped a slide there. To get access at the leadership facilities through Insight or this ALCC, which is Leadership Computing Challenge program. They're both competitive programs that you apply for. There's the link for Insight for resources at Argonne and Oak Ridge. And then there's the link for ALCC, which lets you get a small amount of resources, well, relatively small, but still a large amount of resources at NERSC, Argonne, and Oak Ridge. And then this is just a one-page NERSC summary slide. And I'll end there and let other people talk and either answer questions now or give us more time for questions at the end.
Okay, maybe it'd be good to do the questions at the end. Yeah, okay. All right, so thank you, Richard. Let's see, let me figure out the Zoom again. Let's see, we're going to Susan next, yes? Is Susan here? Yes, she is. You might be muted, Susan.
I'm not anymore.
There you are. Excellent.
All right. Is that working?
Yeah, that's beautiful. Perfect.
Great, thank you. So I'm Susan Maringer. Here at the Center for Advanced Computing, I'm the Associate Director for Consulting, and I lead our virtual workshop online training project. I'm also the Exceed training lead. And so I will do my best to tell you about Exceed in 5 minutes and Frontera in 5 minutes. And I've lost my clock by going full screen. So let me set that up so I don't go overboard. Okay, few slides on Exceed. Exceed is a virtual organization pulling together a number of computational and support resources and a number of services. You want training, you want to get an allocation on one of quite a few machines, you want to find documentation. There is a lot available in one place that is actually coming from a number of different sites. The two main links that I would send you to, the first one on this page tells you about Exceed and its projects overall, and the portal is more the user-facing, how to request an application, get the user guides, see what your usage is, etc. If I read the virtual residency agenda correctly, I think you'll all be well acquainted with the portal soon if you're not already. Which computing resources are available through Exceed? I believe this was my best attempt at the current list. You can see there's a number of computational and storage resources available. And Lauren will be telling you about one of them in more detail very soon. And what do you do with this list? How do you decide what you're going to do next? I've lost my focus. Oh, there we go. So out of that list of resources, what do? How do you decide which of these you'd like to get an allocation on? These 3 bullets are suggestions for where to start. Many people decide based on software. Their code requires a certain set of software. Well, use that link to find out which of these systems the software is available on. The second link, the resource monitor, gives you more detail about each of those resources, such as how many CPUs, what are the peak teraflops, a link to each system's specific user guide, and you can get a sense of how fully loaded that machine is, how busy it is, how long you'll have to wait in queues. And then finally, the third link with resource info, I've given you a little clip of information from that link on the bottom. So you get a description and the recommended use for each machine in kind of a different format and outlook. Hopefully this and the other information you'll find on the portal is enough information to help you narrow down which resource or resources might be right for you. From there, I would suggest the nice, easy ramp up to getting an allocation. What I usually recommend to people here at Cornell is to start out by seeing their campus champion, that's me, and saying, all right, you have it narrowed down to 2 or 3 of these resources. I will put you on my campus champion allocation so you can do a little test run, poke around on those 2 or 3 machines, and then once you see, this is the system that has what I want in terms of software, I know how to use the services here, and it has everything I need. So then your next step would be to go on to a startup allocation, which low cost of entry in terms of the form you need to fill out, the information you need, and the turnaround time is usually pretty quick, usually within 2 weeks in my experience. Oh, sorry, that was me. And then finally, you use that startup allocation to really understand what your research allocation request should be. How much time do you really need, and have you done the proper test runs so that you can justify that you need this size of an allocation on this machine, and you can basically show your work to justify your request. So that's the easiest way to get to your large allocation on Exceed in my experience. Finally, there are education allocations. If you say need something on one of these machines in an academic or a training class that you're teaching, there are allocations available in a special category for those. All of these allocations are, you can request at any time except the research allocation. That's only available for request 4 times a year. If you check that link at the bottom, it's fairly easy to find that schedule. Okay, 5 minutes for Exceed. We're on 5 minutes for Frontera. So Frontera is a new leadership class system that is at TAC. It's not available yet, and I can't tell you exactly where the folks at TAC are in terms of setting this up, because we here at CAC are one of the partners on the Frontera project, but our part doesn't come until later. So I can't say that I've run on the machine yet. But from what I've heard, it is planned to be in operation later this year. So if you look at the numbers, that we'll see on the next page. We might as well jump right there. This is a very large, very fast system. And what you see here on the hardware page is just the main elements. For example, there are also GPU resources, 2 different queues, one with IBM Power 9 nodes and another with Intel-based compute nodes, which total up to over 900 NVIDIA GPUs. And I could go on, but 5 minutes, so I'm going to keep moving on. I should have mentioned on the project page, there are many partners on this project. TAC, of course, is the lead, Ohio State, Texas A&M, various vendors. It's a fairly long list. So who can use Frontera? I didn't get into details on the exceed slides, but the requirements, the bar for who may apply for an allocation is fairly similar to exceed, where if you're doing research at a U.S. university, you're working with someone at a U.S. university. In Frontera's case, preference is given to NSF-funded work. If you are eligible to be a PI on a solicitation at your university, then you are probably eligible to submit an allocation proposal for Frontera. So I think the rest of this is pretty much the norm for these types of systems. So let's move on to getting access. So the NSF PRAC process, the Petascale Computing Resource Allocations process, will be who administers the allocation requests for this system. We're not at that point yet. Right now, there has been a request for early allocation, early users. That's already gone out. They've already gotten a great response to that. And once the machine is truly in production, there will be a formal call for allocation requests through the PRAC process. Now, typically, the allocations will be large allocations, but there are, of course, other ways to get on the system if you have a need for it. Special gateways that should run on a system like this, projects that require the hardware compute ability that are appropriate here. And there is that ability to go for a startup project if you're not ready to request your full large-scale allocation request. One of the things that I didn't mention about this system is that it was architected to be very, to be an easy on-ramp for people who are already working on large queue-based Linux systems. So if you're already working on a system like that, migrating over to Frontera should not be a onerous task. Frontera will have a very large support component, everything you'd expect, plus more, and then more on top of that. So pretty much anything you can imagine in terms of support is on this list. And if not, try writing to their help desk, and I wouldn't be surprised if they didn't find some way to help you with that too. Finally, here are some links I would suggest you try. The main tax site has an information page on Frontera. There is already a user guide available on Tax Portal, and Dan Stanzione, the director of TAC, you can watch him on YouTube talking in about Frontera. I do want to thank Dan for his slides that I used. All of the correct information is from him. Anything that's wrong here is an error that I introduced. And that's it. Thank you.
Thank you, Susan. You know, you did a fabulous job squeezing all that in. I think we could go on for hours. And so next, I'd like to ask Lauren Michael to talk about open science grading. See if it works. There it is. Yay. Lauren, are you muted or talking?
There. Sorry, I had to find how to unmute once I was in screen sharing mode. So I am Lauren Michael. I'm a research computing facilitator at UW-Madison and our campus's core research computing facility. And then I also lead research facilitation for the Open Science Grid, which is a consortium of campuses, institutions that share computing and data resources so that it can be used for distributed high throughput computing by researchers at those participating organizations and by individual researchers that just connect to OSG individually. So I'll talk about the service in particular that is available to individual researchers in addition to how institutions can participate in the Open Science Grid. But together, this is really over 125 institutions that share resources, delivering work to many hundreds of projects and thousands of researchers, really. Some of these projects are quite large. All right. So what is the Open Science Grid? And I'll leverage the definition for the term grid just a little bit. A grid is sort of a coalesced set of computing resources that are really made up of independently owned and otherwise autonomously managed computing systems. So what we mean by that is that in the Open Science Grid, for example, there are institutions, whether they're campuses or national labs, that have large computing systems. And through technology that is produced by a core group of people in the Open Science Grid team, we are able to backfill or otherwise opportunistically use computing capacity and even some data capacity at a number of sites that are contributing, and to make that available to participating organizations and individual researchers as if that's one big computing system where their data and their software are mobilized in order to reach all of these different resources. And so it's really a computing system that's meant for distributed high throughput computing, which is kind of a specialized form of high throughput computing. And I'll talk about what high throughput computing is from our perspective and where the distributed component can help you as facilitators or as even researchers determine when and how you can best take advantage of the Open Science Grid. So we have a team of people that contribute largely partial amounts of time to the core OSG team. I lead efforts to facilitate participation in OSG by individual researchers and by institutions and large collaborations. So even when a campus is contacting the Open Science Grid because they're interested in contributing their excess capacity or perhaps having a local submission point, they start off by having some personalized guidance with myself and then any number of team members that we pull in depending on what other technology resources that campus might need in order to meet their integration goals. And then otherwise, we've got research facilitators who meet with every researcher who accesses OSG through OSG Connect. For researchers who don't have access via a local submission point at their campus or institution, OSG Connect is available to those individuals. And I'll talk about OSG Connect in just a bit too. But first, I want to talk a little bit about high throughput computing because I think high performance computing is a really sort of commonly understood term. High throughput computing really plays out well in this analogy that we use to describe to researchers, how would you make the world's largest cake, which I think the record is still from the Las Vegas Centennial in 2005. Since it was 2005, you'll have to forgive the very pixelated pictures. But they didn't sort of, make one really large oven in order to make the world's largest cake, as you probably can imagine. Instead, they used sort of run-of-the-mill computers. They sent, or not computers, ovens, and sent out recipes and ingredients and even the pans to individual homeowners so that they could contribute by baking numbers of cake pieces that could be assembled later. And this is very much sort of the way that we describe high throughput computing. If you've got problems that can break up into pieces, that can run on single cores or very few cores in relatively reasonable amounts of time, which I'll talk about, the Open Science Grid, because it has this vast amount of excess capacity across hundreds of computing systems, can really provide an advantage for that type of work. But you can even have high throughput computing systems on a local scale like we do at UW-Madison. And versus trying to tackle these problems with some form of internal parallelism like multi-threading or MPI, by running lots of tasks with a single core, even on a local computing system, the scheduling means that those jobs wait in the queue less because there are frequently more single cores that are available rather than chunks of a specific number of cores. So there's also a faster time to reach the peak number of cores across a set of work. If one of these tasks fails, you can have built-in redundancy. And in fact, on HT Condor scheduled compute systems like the Open Science Grid and our local system at UW, there are mechanisms already built in to automate retries and failure handling, et cetera. But even if it's a problem where in Open Science Grid, power is lost to the execute server that's running a job, or it has a network issue, it just gets requeued automatically and run somewhere else. This is part of how we deal with the fact that in the Open Science Grid, your jobs may be running in a sort of backfill mode where they can be interrupted at any time, but the compute system will always just put them back in the queue and find somewhere else to run them. Without needing internal parallelism, this means that there's no special programming required. High throughput computing can be a really useful tool for people writing their own codes. The number of concurrently running jobs matters a lot more in terms of your overall throughput rather than CPU speed and homogeneity, as is the case for sort of traditional HPC. And that's because when you've got access to orders of magnitude more, number of cores, for example, you'd have to be making orders of magnitude increases in CPU speed or even code performance to compete with that. So is a problem HTCable? This really comes down to whether it can be divided into sort of a number of pieces. And there are a lot of research applications, particularly in the life sciences, social sciences, and humanities, things like text analysis, which DNA read mapping and other genomics really falls into that category. But there's a wide variety of text analysis that's not genomics, and there's a wide variety of genomics that most people don't think of as text analysis, but that is effectively lots of tasks, or could be run as lots of tasks. With read mapping, for example, individual reads can be mapped. Statistical model optimization, running lots of different statistical models by similarity, parameter optimization, running lots of computations, each with a different starting set of parameters. You can do in a high throughput way in brute force. You don't even need a smart algorithm if you've got access to a large scale high throughput computing system and the power, for example, of the Open Science Grid. And then anything else that is really well described as multi-image or multi-sample analysis, like medical imaging studies where each image needs to be analyzed separately and you've got tons of them, or we've got some astronomical studies that are processing images from the sky. There really are a wide variety of applications that can benefit from high throughput computing, but then especially the scalability of Open Science Grid. And to answer the question of, is it OSGable? I've made this table that I won't go into significant detail on since you can look at it later and it's kind of extensive here. But the ideal jobs for Open Science Grid can finish in less than about 12 hours on a single core, with a few gigabytes of memory, input of less than 500 megabytes, output of less than a gigabyte. And your software needs to be somewhat portable, or there are ways that we can make it available through OSG's sort of core software modules. The main limitations on software are that we can't really run licensed software or any non-Linux software, since Open Science Grid is all Red Hat-based Linux. But there are still a number of situations where your compute requirements per job may exceed this, and where Open Science Grid still makes a really huge difference. So when I say ideal, I mean that's where people can get up to 10,000 cores running across all of their sets of jobs. For individual researchers, we have OSG Connect. It has a lot of the things that you would expect. One of the differences is that we meet with every researcher in part to verify that they have an institutional affiliation with a US academic, government, or nonprofit organization, but more importantly, to help them get off on the right foot in using high throughput computing in a distributed way. We also provide, additional storage by request for large input. And there's a lot of built-in data caching in Open Science Grid to help deliver even large files per job out across the Open Science Grid. I'll leave these numbers up here too, but this just demonstrates through OSG Connect alone the number of projects we have going. These include some allocations that people request through Exceed, but the secret is that you really don't have to get an allocation request. You can come directly to OSG Connect and there are no allocation limitations. We have a number of people who frequently exceed, even by orders of magnitude, what their initial Exceed allocation was, if that's the way they came in. But we really only have about a dozen of those per year. The integration services for campuses, basically start with, you can either have a login node at your own campus that submits to sort of your own Condor pool that then is populated by machines from Open Science Grid. You can have what's called a CE or compute element if you want to contribute resources to Open Science Grid that talk with your compute cluster and can add resources both to your Open Science Grid pool and directly to the Open Science Grid to be used by others. There are various ways to leverage the same types of data storage that we have through OSG Connect from a campus perspective, where your storage cluster can be sort of the origin for data that then makes it all the way out to the Open Science Grid. You can, through the Condor scheduler, have additional capacity added from the cloud into your local pool. And this can even be done in a way that supports science gateways, et cetera. And OSG can support a large set of the hardware here. The really important component for campuses, I think, with login nodes that would allow their own researchers to submit is that you still need to support this and facilitate your researchers like you were otherwise investing in and operating your own compute system. So that's where researchers or campuses decide on whether to send people to OSG Connect versus having their own login node, for example. And if you want to read more about the importance of high throughput computing, the National Academies of Sciences talks significantly about the different fields, in particular, those that have been using large scale computing less in the life sciences, social sciences, and humanities, and how high throughput computing is becoming very important, especially at a scale like Open Science Grid, beyond which a campus could typically provide capacity. And then I'll take any questions when we go to that, but I've got contact here for following up.
Cool. Thank you, Lauren. Super awesome. Again, we're going to hold questions till one more. And I think, Frank, if you're around, and I confess I've only ever read your name, so I don't know if it's Witzman or Weitzman. Hopefully Frank's here and not in the zombie Zoom room. In case you don't know, you're missing all the fun. There's a whole other Zoom room that got zombified after the breakout sessions earlier. I did put in a support ticket with Zoom, with the room number.
I'm seeing you.
Yeah.
I see you.
Yes.
You see who where?
Right.
Oh yes. Bye, Frank. Let's see if you can. Let's see if we can hear you.
It's muted.
I hear his mouse clicking.
You muted? No, because I'm not.
Okay, can you hear me now?
Yes, that sounds terrific. Thank you.
I think I had the same problem that Lauren had. I couldn't find where to unmute when I switched to the screen share mode. Okay, yeah, Dana, thanks. You did a great job for the introduction. It's Frank Witzman. So I'm the Associate Director for HPC Centers for the DoD High Performance Computing Modernization Program, the HPC MP. And I live and work out of Wright-Patterson Air Force Base in Dayton, Ohio. But we are very much a distributed organization. We're actually run out of the Army Corps of Engineers at the Engineer Research and Development Center in Vicksburg, Mississippi. That's where the headquarters is for this program, but we're a DoD-wide program with people all over the country supporting this activity. As a DoD program, we do HPC support for DoD mission priorities in the research, development, test, and evaluation arenas. We don't support operational mission for the Department of Defense. We're just supporting most of the research that leads to warfighting capabilities. We do allocations based on primarily our three main services within the Department of Defense: Air Force, Army, and Navy. We allocate 30% of our resources each to those three. And then our other service groups within the Department of Defense, we allocate 10% of our resources for them. As I mentioned, we do support research, development, test, and evaluation, or science and technology test and evaluation for the DoD. And recently, we also started to support what we call acquisition engineering. But that's very early engineering analysis and analysis of alternatives and simulations that may lead to war games and things like that for acquisition purposes for the Department of Defense, for specific weapon systems, let's say, for example. So I want to focus the rest of my time on three components there to the right. hardware, network, and software. I'll start with software. So our DoD HPC program also provides capabilities in terms of software development. We do build apps for our user base. We try to get them to use scientific codes, engineering analysis codes that we build because they're sort of tailored for our capabilities and do solve a lot of DoD high priority programs and problems with those programs. We do have very extensive training and user support as well. For users that bring their own software, bring their own apps, we do encourage that quite a bit. And we do reserve a lot of resources and give a lot of support to what we call our frontier projects. They're the projects that demand very high levels of resources from our systems on an annual basis, say hundreds of millions of core hours and things like that. And they tend to use a lot of a large portion of each of our large systems as well in terms of core counts and data and memory. On the networking side, you may be familiar with the DREN, the Defense Research and Engineering Network. That is also a component within the DoD HPC program. It's funded by the program. DREN, it's a 100 gig backbone. It's really the commercial provider there for the backbone is CenturyLink. We're using their commercial backbone, their 100 gig backbone for our network. We have roughly 160 or 170 DREN nodes that exist, and those nodes connect our supercomputing resource centers together, as well as Department of Defense networking enclaves that exist at multiple Army, Air Force, and Navy bases across the U.S., as well as other institutions that have DoD work. We also have a classified layer that runs on top of that, an isolated classified layer at the secret level called SDREN, and that has roughly about half as many nodes, probably 70 to 80 nodes. Same concept, it just interconnects our HPC resources with other enclaves that exist at other DoD sites and some of our customers or partners. This is a DoD program. We have a very robust cybersecurity component as well, and that fits within the networking and security area. The last area is my area, the DoD Supercomputing Resource Centers, the DSRCs. Roughly half of the budget and half of the people exist there. There's, the whole program is about $250 million a year with about 700 staff members, and I have roughly half of that in my component within centers. We have 5 major resource centers that house our HPC systems. And there's roughly about 24 or so, 22 systems that we have across those 5 centers, 50 to 60 staff members at each one of those centers. I have some cross centers people as well that do what I call enterprise activities that spread across all 5 of those centers. And our systems are not nearly as large as the DOE or NSF systems. We don't have that scale. We do have one system that's over 200,000 cores. It's roughly a 7.8 to 8 petaflop system. Most of our systems are in the 4 or 5 petaflop range, around 100,000 cores or less. A little over half of our systems do unclassified work for the Department of Defense, and the rest are doing classified work. We do have one system. It's an older system, an older Cray system. It has about 15,000 cores that does open science or open research. That's Department of Defense research that's in the open domain. It doesn't have any sensitivity to it. There on the bottom line is we do have partnerships that we have with other federal agencies. The PEOs, the PEMs, those are the folks within the Department of Defense that own the money for the weapon systems programs, and we interface with them in terms of what their requirements may be from a research, development, test, and evaluation perspective, and where HPC is needed for them. And then also a lot of partners and customers we have in both industry and academia. Really all you need is a DoD sponsor for your work to be able to get access to these resources. HPC.mil contains a lot of the information if you're interested. And with that, I think I will close, and if I have any time left, I will surrender that rest of my time to the panel. Thank you.
Thank you, Frank. All right, so now we've seen all sorts of free, somebody's paying for it, right? National resources, so some things to think about as you're working on your questions and discussion topics is, like if you're helping a researcher, and you're trying to figure out what might help them get their work done faster and better and smarter. We have all these folks here that can help you understand when a researcher's workflow is right for these resources. So I'd like to invite you to say stuff and ask questions. And what do you got? So first, do we have any folks in the room who probably, Exceed and OSG are probably the most common, so I'll start there. Have any of you worked with Exceed resources or helped researchers use Exceed resources? Some. Was it a pleasant experience? Wait, no, you had just, yeah, okay. We want to make Susan feel good about her work. And then what about Open Science Grid? Yeah? Terrible? Oh yeah, well, we have physicists in the room. Let's see. What else do we have? I haven't personally used OSG. I've sent people there, which apparently they had a good time because they didn't come back and complain to me. And training resources. I haven't had any experience with the DOE or DOD or DOE. Losing my letters now. Anybody have DOD or DOE? Oh, of course you do. Air Force Base.
I know people that work with it as far as front job.
Yeah.
They get it without me.
Right. Okay, so now that I've exhausted my prodding capabilities, do you have any questions, comments? Henry?
So for each of so I'll skip Exceed because many of the folks, how many of the folks in the room are campus champions or are campus champion institutions? Okay, so many of the folks in the room are campus champions or have campus champions at their institutions, so I'll skip Exceed. But for the other three, what does a research computing facilitator do to get local researchers onto that group's resources? Is that a good question?
Mm-hmm.
Okay. So, Lauren, you start.
Happy to. So for Open Science Grid, if your campus doesn't have its own submission point, then you can point them to OSG Connect. And if you'd like, you can be CC'd as we get them started. We do this especially for campuses that are thinking about getting submission points so that they can kind of learn the ropes of facilitation OSG. And then for campuses that have their own submission point, they are fully responsible for facilitating their own researchers, of course, using us as a sounding board or checking in for additional help.
Okay, NERSC and DOE.
Sure. So for NERSC in particular, the first thing to check out is if the research group you're working with has Office of Science funding. So talk to your PI, whoever that is, and see if they already are using NERSC, or if they're not, you can go to our website and find the instructions on how to apply and all that sort of thing. The thing to remember is that the applications will be reviewed by a program manager in DOE, possibly the one that gave the research grant in the first place. For the leadership facilities, again, any group can apply through Insight, and they've got the link on my slides. And just go in there and look at the deadlines, which I don't remember off the top of my head, and fill out the application form. Now, we also have, I heard people talking about accounts for classes and for events. We also have the ability to do that, and in that case, they can just contact our allocations email list, which you'll see on our website also. And if the class or the event has some relationship to the Office of Science, which again is pretty broad in terms of science areas, we can set up either time for a course that's being taught at a university, or for some kind of a large training event. About half of our 7,000 users are at universities, so we probably have at least one or two to up to hundreds of users at any given university in the U.S. that does this kind of thing.
Thank you. And Frank from DoD.
So who asked the question, please, and could you repeat it?
Yeah, hi, I'm Henry Neiman from the University of Oklahoma. So the question is, what would a CI, cyber infrastructure facilitator at one of our institutions do to help their local researchers get onto the HPC modernization programs systems?
Okay, good, yeah. So first of all, hi from Christine Quickie.
Hey.
She's doing well. She wanted to say hi. Yeah, so as I mentioned, if a researcher has any connection to any kind of Department of Defense activity at all and has a requirement for the use of HPC in doing any science or research or engineering work, it's typically how it happens here in our program is that person would make a connection with a DoD sponsor. We don't really have a good list of DoD sponsors or principal investigators or project leads. It's typically done through interpersonal connections.
Great. So I'm trying to show you the audience via my video.
And could I answer Henry's question as
Yes,
well
please,
for Frontera, not for Exceed?
Okay.
So as I mentioned, if you know or have somebody that thinks they would be the perfect early test user, send a ticket in through the TAC user portal. And the other advice from TAC at this point is if you want to start getting your research community ready to onboard to Frontera when it has gone production, the best thing you can do to get those users ready is to get a startup allocation on Stampede 2 and use the Skylake nodes.
All right. Dan, you have a question?
Yes, my user base uses HIPAA data. Many of your resources allow HIPAA related research.
Did you hear that?
Could you repeat it?
His users use HIPAA data. So are you able to accommodate HIPAA data?
Well, I can say at NERSC right now, no, we are not.
Okay. No at NERSC. DoD? Sure. No.
No at DoD, not yet.
Lauren? Oh, Open Science Grid, I'm guessing no.
Short answer is no.
Okay. Is there a long answer? Not that we want to hear it, but.
Yeah. I can make it a short, long answer. If you have your own local pool with your own submission point, you can add Amazon resources, and there is a potential to make that HIPAA compliant.
Cool. So Susan, you probably have a much longer answer.
Well, unclassified data is okay, but not private data, I believe.
Right.
And HIPAA data is probably private data, isn't it?
Yes.
So I believe not yet.
Anything else?
Get another picture.
What? Get another. Lauren, say something. Debbie wants to take your picture.
Take my picture.
And smile while you're making noise. She
I
said,
think the lighting is probably not great because
it's beautiful. It looks like one of those Renaissance portraits with the light coming in from the side. Lovely. Thank you all very much. Let's give the panel. All right. Okay. Thank you all very much. Really appreciate it. I accidentally gave everyone your email addresses, so you might get questions. And so with that, I think we're going to completely shut down every Zoom instance on the planet and hope that the zombie room comes back. Okay.
Yes.
Okay. Thank you, Lauren. Thank Frank. Thanks, Susan. Thank you, Richard. Yay. Okay. Let's turn it off.
Yeah, everybody who has a Zoom connection, disconnect. End meeting.